In this video, we are going to talk about solving linear equations in one variable. Okay, so an equation, we'll just start off with an equation, which is a very general thing. So it's just a statement expressing the equality of two mathematical expressions. So just some mathematical statement involving the equal sign like this right here. So here's an equation, 3x plus 5 equals 10. And 3 times a plus 2 equals 14a. Okay, so these equations are both examples of what are called linear equations. So a linear equation is just any equation that can be written in the form ax plus b equals 0. Okay, where a and b are real numbers and the number a is not equal to 0. So that's called a linear equation or a first degree equation in one variable. All right, so it's some number times x plus another number equals 0. All right, if you go back and look at the equations that we had on the previous slide, what we have is 3 times x plus some number, that looks good, equals 10. So that doesn't fit exactly this format where that we talked about here, and that it's 0, but that's okay because as we will see a little later on, this equation can be put into that form. Okay, so at first it might not look totally apparent, that the equation you're talking about is a linear equation. Since this is the first section that we're talking about, well, the equations that I give you are going to be linear equations. But as we go forward, we'll look at more complicated types of equations, and then going through there, I'll kind of point out where you can, what things you can look at to tell what type of your equation that you're dealing with, because it is important that you do that. Here in this equation, this is also a linear equation, and it really doesn't look anything like the format in this slide here. It doesn't look like this. But we can easily do some things to this equation to make it look like the standard linear equation in the other slide. And we'll talk about how to do that a little bit later. Okay. Here in this equation, we are using the variable a. A lot of times you're probably used to using the variable x, and a lot of times we will use that. But you still need to get used to using these other variables. If you go to take other classes, like just say, for instance, economics, where they talk about price and quantity in equations, they're going to use variables like p and q because that's just traditional in their field. Okay, and so you do have to get used to solving variables with other letters other than x in here. So it's good to practice that. So we will see that some in this class. Okay, so what we want to be able to do is to solve equations like this. And so to know what you're doing there, we need to know what a solution is. Okay, so a solution, it's also sometimes called a root of an equation. It's any number that yields a true statement when the variable, when that value is substituted in for the variable. So for instance, we have the equation x plus 2 equals 5. And we are saying here in this example that 3 is a solution. So how do you know it's a solution or not? Well, when you take and put that 3 in for the variable, in every place where the variable occurs, this becomes what's called a statement. And a statement is something that's either true or false. And so you can work this out. We all know that 3 plus 2 equals 5, right? And so we get 5 equals 5 here. All right, and that is a true statement. So when you actually plug the number in, a number in for the variable x, you'll get a statement. You can decide whether that statement is true or false. And if it's true, like in this case, then that number that we plugged in is a solution. So we would say here that 3 is a solution of this equation x plus 2 equals 5. Okay. All right, let's take a look at the next one. All right, in the next little example there, it says the number 2 is not a solution of the equation x plus 2 equals 5 because 2 plus 2 is not equal to 5. So again, right, if we have this equation and we want to decide, hey, is 2 a solution to this equation or is it not, right? Then what we could do is plug 2 in for the variable in all of the places where it occurs, right? And when we do that, we get, again, what's called a statement. That's something that's either unequivocally true or false, right? Here, 2 plus 2 is 4. So this statement is 4 is equal to 5, which we know is false, right? That is a false statement. So the conclusion is that 2 is not a solution of this equation x plus 2 equals 5, okay? So it's really pretty straightforward to decide whether a number is a solution or not a solution. If you just plug it into the equation and work that out, you'll get a true or false. If you get a true, it's a solution. If it's false, then you will that number is not a solution. Okay, so that's what a solution is. Equations that kind of can be broken down into a few different types. The type that we will deal with mostly are what are called conditional equations, and conditional equations are equations for which some numbers are solutions and others are not. Okay, so for instance, x plus 2 equals 5, we saw that 3 was a solution and 2 was not. So x plus 2 equals 5 is a conditional equation. And most of the time, that's the type of equations that we're going to be dealing with. Other types of equations are what are called identities. Identities are equations for which every number in the domain of the expressions involved is a solution. So for instance, x plus 2 equals x plus 2 is an identity. It really doesn't matter what real number you plug in for x, right? You're going to get a true statement no matter what. Whether it's a 0, a 5, a 7, any number is going to be a solution of this equation, and so therefore that's what's called an identity. All right, inconsistent equations are equations with no solutions. So here's an example, 2x plus 5 equals 2x plus 7. That's an inconsistent equation. Because I don't care what number you plug in for this, right? It might not be apparent at first, but over here on the left side, we have 2x plus 5. So whatever number we're plugging in for x, we would times it by 2 and then add 5, right? Over on the right side, we would times that number by 2 and then add 7. So we're taking the same number and adding 5 on one side and 7 on the other side. So these, no matter what number you plug in, they're never going to be equal to each other because this side over here is 2 bigger than the left side, okay? So it doesn't matter what number you try to plug in here, it's not going to work. All right? So those are the 3 types of equations. So when we say we want to solve an equation, what we want to do is to find all solutions of the equation. Okay, so find all the solutions. And so we've already seen that it's pretty easy to check to see if a number is a solution. You just plug it in, right, and work it out, and you can tell. But so you might say, well, one strategy, would be just to guess and check, right? You could do that. I guess, what a solution is. I plug it in and see if I'm right or not. Okay. But that's really not a very good strategy for trying to find every single solution, because there are infinitely many numbers to try, right? And so that means the process is you can never really be certain whether you have found all the solutions or not. Okay, so what we want is a more systematic way of finding all the solutions. And the way in which we're going to do that is through what are called equivalent equations. So equivalent equations are equations that have exactly the same solutions. So for instance, x plus 2 equals 7 and x equals 5 are equivalent equations. All right, so um, just to give you an example of some equations that are equivalent. So looking at x equals 5, right, this equation over here, we can see that clearly, right, there is only one solution. This one is so simple, right? We know that the only way that you are going to get a true statement is if you plug in a 5 for x, you will get a true statement. If I plug in any other number besides 5 in here, I am going to get a false statement. So 5 is the only solution. Over here on this equation, right, if I plug in a 5, I will get, again, a true statement, right? 7 equals 7. So I know that 5 is a solution, right? And in fact, it is the only solution to this equation. For right now, you just have to kind of trust me on that one, but you can probably see, right? If I plug in any other number besides a 5 here, again, it's not going to come out to be 7. So, all right, so these two equations are equivalent to one another. So this idea kind of illustrates what we want to do with an equation to solve it systematically. Is what we want to do is we want to start with a more complicated equation and boil it down to one that's really simple, like this one over here. Okay, and then we can just read off the solutions from there. All right. So that's essentially what we want to do. The thing is that you have to make sure that you stick with doing certain things to the equation. You can't change the equation too much without changing the solutions. Okay, so what we're going to talk about are two basic ways that you can change the two basic things that you can do to an equation and not change the solutions. Okay. All right, so the first one is called the addition property. So if I have an equation that looks like this, a equals b, right, and I add or subtract the same number to both sides of the equation, then the two equations will have exactly the same solutions. Okay, so adding or subtracting the same number to both sides of an equation will not change the solutions. All right, so we can use that to our benefit to solve this linear equation right here. So let's take a look at walk through how we would do that. All right, so we have x plus 4 equals minus 3. So when you have an equation that looks like this, the first thing that you would want to do, right, is to simplify both sides as much as possible. And here, this side is as simple as it gets. Negative 3 is just negative 3. There's no changing that. Also, over here on the left-hand side, this is as simple as it gets. X plus 4, there's really nothing more that I can do with that algebraically. I can't combine these two into one term or anything like that because it's addition, right? I'm adding these two terms, and I can only combine like terms with addition. So in other words, if this had an x in it, then I could combine these, but it doesn't. So each side is as simple as I can get it. So what I'm going to do then is, after you get each side as simple as you can, you're going to use the addition property. Okay, and the addition property says you can add or subtract the same number from both sides. The goal here is always to get the x, or whatever variable it is, by itself on one side of the equation. All right, so what I'm going to do is I'm going to subtract 4 from both sides of this equation. All right. And I usually just write it down below. Some people will write the minus 4 on the same line as the original. However you want to do it's fine. Okay. And so what's going to happen here is now I can combine some like things. If I have x plus 4 minus 4, right, that plus 4 minus 4 comes out to be 0. So I'll have x plus 0, and I'm not going to bother to write the plus 0 on there. Okay. Because anything plus 0 is just itself. So that means on this left side, what I've done is I've got the x by itself on one side, and that's one of the goals when you're solving these linear equations that you want to do. All right, and then over here on the right side, rather, I have -3 minus 4. That's going to come out to be -7 when I do that. Okay. All right, and so I've got the x by itself, completely by itself on one side of the equation. It's very, very easy to see that this equation only has the solution of -7, right? That's the only number that you could plug in for x to get a true statement, right? And so since I added, or in this case, subtracted the same number from both sides, then I know that the solutions of this equation are exactly the same as the solutions of the original equation. So I have found all of the solutions to this equation here. Okay. So the only solution is -7. All right. So that is using the addition property to solve a linear equation. All right, the next property is the multiplication property, and the multiplication property says that you can multiply or divide both sides of an equation by any number you like except for 0, and that will not change the solutions of the equation. Okay. All right, so that's what it's saying here. So again, you can use that property to solve linear equations. Okay. All right, let's take a look at this example here. So here I have a very simple equation, -3x = 18. Okay. So in general, you want to make sure that each side is as simple as you can possibly get it. There's no simplifications that you can do, and that's the case here. I have 18. That's as simple as it can be. -3x, that's as simple as it can be. Okay. Then after making sure that both sides are as simple as you can possibly get it, then generally the next step with these linear equations is you want to add or subtract numbers to both sides, and the goal is to get every term with an x on one side, every term without an x on the other side. You can see in this equation, right, that is already the case. Every term with an x is over on the left side. Every term without an x is over on the right-hand side. Okay, and so we don't have to use the addition property here like we did in the previous example. Okay, so once you have every term with an x on one side, every term without the x on the other side, then you are going to use the multiplication principle. The multiplication principle says you can multiply both sides of the equation by any number you like except for 0. You can't do that, and it will not change the solutions. All right. So remember, the goal of solving these equations is to get x by itself on one side of the equation. Okay. And so here I can do that by dividing both sides by -3. Okay, remember, as long as you divide both sides by any number, you can divide both sides or multiply both sides by any number you like except for 0 and not change the solution. So that's what I'm doing here. That's what I'm doing here, right? And then over on the left-hand side of the equation, I have -3 divided by -3, which would be a +1. Okay. And so this would be +1x, and I normally don't write the +1. So you normally don't do that in algebra. If I've seen some students do it, and that's okay. You can write it there, which is fine, but normally you don't write that. Okay. All right, and so you can see that accomplishes the goal of getting the x by itself on one side of the equation. All right, and then 18 divided by -3 is -6. All right. And because I used that multiplication property, I divided both sides by the same non-zero number, right? I know that the solutions of this equation, right, this one I ended up with, are exactly the same as the solutions of the original one that I started with, okay? And that's important, right? Because this equation, I can just read off the solutions. The only solution to this one is -6, right? That's the only number you could plug in for x to get a true statement here. Okay, and so same thing up here, because we use the multiplication principle. Okay. All right, so if you stick with the addition principle and the multiplication principle, then you don't change the solutions, and you can systematically solve these linear equations. Okay. All right, in the next video, we are going to start working through some examples of more complicated equations, so make sure you take a look at those.